Alright, so today we're going to continue looking at this free-falling object problem. In the last video, we found the position and the velocity at 1 second. Now we're going to look at 4 seconds. So just remembering from last time, our only given in this problem is that the initial velocity of the ball is 15 meters per second in the up direction. This question is just modeling a ball's motion when you throw it up into the air from a tall building. And as I said before, we're looking for the position and the velocity at t equals 4 seconds. So just like in the previous part, we're going to need these two equations here, the position equation and the velocity equation for the motion. And this is our diagram for the problem. So we define a coordinate system, the up as positive, and so we drew the ball here on the tall building, and this is the general motion it will follow, as well as the two vectors that we have here is the initial velocity and the gravity vector, noting that the gravity is going to be negative 9.8 meters per second squared. So now we can start solving. So we can start with solving the position at time equals 4 seconds, and that starts with the position equation here, and then we can use the values that are given in the problem, which we can plug into the position equation, getting this expression here, and then we can start by multiplying the two amplitudes. 15 times 4 equals 60, and then we can multiply the units, meter per second times seconds. Seconds cancel, we just get meters, and then we can bring the square into the brackets here, and then we get 16 seconds squared, remembering to square the units and the amplitude, and then we can plug those two values back into the equation and get this expression here, and then we can evaluate this term starting with the amplitude. So 1/2 times negative 9.8 times 16 just equals negative 78.4, and the units, meters per second squared times seconds squared, the second squared is canceled, just leaving meters, and then if we plug that back in, we get this expression here, and then we do 60 meters minus 78.4 meters, and we get our final answer equal to negative 18.4 meters. And I just want to note this represents the ball's height at time equals 4 seconds. So if we see the motion here, and we have a reference point y equals 0, and so the ball is going to be actually under the initial position since it's negative, and the spacing right here is going to be equal to negative 18.4. So now we can look at finding the velocity at t equals 4 seconds. So if we start with the velocity equation and plug in the values that we already have, we get this expression here, and then we can just evaluate this term here. So negative 9.8 times 4 is negative 39.2, and meters per second squared times seconds. One of the seconds cancel, leaving us with meters per second. So then if we plug that back into the equation, we get this expression here, and then we do this simple subtraction, and we get the final answer equal to negative 24.2 meters per second. And this will represent the velocity at t equals 4 seconds. So we can draw a diagram here, and we know that the position of the ball is going to be right around here, and we can see that the velocity at this position is going to be negative 24.2 meters per second in the down direction. And so I just want to show what we solved for so far in part A. So we got our ball at our starting position, and then we got the ball at t equals 2 seconds, and then at the ball at t equals 4 seconds here. And then we know the initial velocity is 15 meters per second, the velocity at 1 second is 5.2. And what we solved in this part, we have the position equal to negative 18.4 and the velocity equal to 24.2 meters per second at the t equals 4 second time.